Welcome to another edition of Tips from the Lathe Cave. From deep inside the Lathe Cave, somewhere in southwest Michigan, this is the Viper. In this video, we're going to be chambering a Remington action, a standard factory Remington action, untrued, just the way it comes from the factory. We're doing this for the home hobbyist because there's an awful lot of home hobbyists out there that would like to be able to chamber their own rifle barrels in a timely fashion, and they'd like it done right, and they'd like the confidence in knowing that it was done by themselves. Now, there are going to be a few items that you're going to need: a micrometer, a depth micrometer, reamer, go gauges. All those we'll cover later on in the video. I happen to have in my repertoire a special tool, and that's a box of voodoo chicken bones, because I always thought that chambering a rifle barrel was black magic. So I purchased these from a young lady in the islands, and they've come in very handy, so I do keep them around now and then. Again, this video is being shot for the home hobbyist, not the professional. We're going to show you how to do this step by step so that it's done safely and accurately. And in regards to that, I have to make one statement that is my own personal belief, and that is that there is only one right way to chamber a rifle barrel. Now, there may be many different methods and techniques that one can apply to accomplish this task. Each craftsman has his or her own technique, but the end result must be the same: a straight and concentric chamber that is straight and concentric with the bore. However, or whatever the person doing the work does to achieve these two objectives is the right way. In front of you, you see a worksheet for the Remington action. It shows the location of each dimension that needs to be taken. On this side, it actually gives you the formulas that you need for determining the proper measurements and what to do with them. And it's got places on the bottom so that you can put your measurements down and make various notes. I am offering this to anyone who wants it. All they have to do is email me through my website, www.viper-rest.com, and I will email this to you. This way you could make several copies of it and have them. You should have one of these for each action that you do. After you finish doing your action and you take your final measurements, as long as everything agrees with the measurements that you took at the beginning and everything's copacetic at the end, then you should take one of these sheets and make it really neat and then laminate it and write down what action it's for. This way you'll always have the measurements when you need to rechamber another barrel for that action. Again, this is free. All you have to do is email me, and I'll email you a copy of this, and you can make as many copies as you like. This was presented to me courtesy of the Research and Development Department at Brownells. I'd like to thank Mr. Mark Tiguano for helping us with that. Alright, it's time now to get some measurements off of the action so that we can continue the chambering process. Now, these numbers are absolute, so you have to take these measurements extremely carefully and make sure that you write them down, because each one has a specific reason and they have to be done correctly. The first measurement you want to take is from the bolt face to the end of the action, and you use a depth micrometer when you do that. And you take that number and you write it down. The second measurement you want to take is from the face of the bolt lug to the end of the action, and write that number down. The third measurement you want to take is from the front edge of the bolt nose ring to the end of the action, and write that number down. The fourth measurement will be the width of the recoil lug. Now that we've taken all the pertinent measurements off our action, it's time to remove the bolt and disassemble the bolt by removing the fire control mechanism. And in order to do that, we need a special tool. It's called an KW Kleinendorf tool, It's sold by the Brownells Company. Now there's no need to remove the trigger assembly from the bolt, but it is helpful to be able to know how it operates. In order to get your bolt to release, you must lift up your bolt handle, and you have to push up on the lever next to your trigger. This will allow the bolt to slip out of the action. Again, push up on this little button right here, and that releases the bolt. Now once the bolt has been removed, you take the Kleinendorf tool, slip it over top of the shroud on the bolt, locking it into the first position, this position right here, with the cam, the hook that's on the Kleinendorf tool, and simply push down on the handle and release the pressure on the bolt. Now all you have to do is unscrew it, and you've removed the fire control mechanism. This is your fire control mechanism. It's comprised of the firing pin, the spring, and the shroud. Once that's accomplished, release the pressure on the Kleinendorf tool, remove it, and put your firing pin in a safe place. You will not need it for the rest of the chambering. Now that we have the measurements off the action, we need to know what to do with them. We know that our recoil lug is 0.250. The tenon diameter is going to be 1.060. We know that the measurement from the lug to the front of the action is 0.715. We know that the measurement from the bolt face to the end of the action is 0.711, and we know that the measurement from the end of the bolt nose ring is 0.581. Now we can determine the other measurements that we're going to need to machine. The tenon length, the way you determine that is you take A, which is 715, plus the width of the recoil lug, which is 0.250, and you minus 10 thousandths from those two numbers, and you come up with 955. This is going to be the overall length of our tenon. So we have that measurement now. The next measurement we're going to need is the bolt nose recess. That's where the bolt nose has to fit into the back of your chamber. You take measurement A, which is 0.715, and you minus measurement C, which is 0.581, and you come up with 0.134. Then you add the recoil lug, which is 10 thousandths. So you come up with 1.44. That is going to be the depth of your 0.708 diameter cut. That's your recess cut, so the bolt nose has someplace to fit into. That'll give you the proper clearance. The next measurement we're going to be calculating is the protrusion of the go gauge. Now this is the only one that can vary, because it depends on the guy who's making the go gauge. It could be a couple thousandths less, a couple of thousandths more. That's where the feel, when you test the go gauge in your chamber towards the end of the chambering process, comes into play. However, this will give you a general number to deal with. You take measurement B, which is 0.711, and the recoil lug, which is 0.250. You add those two together and you come up with 0.961. And then you minus the tenon length, which we've already come up with 0.955 from that number, and you come up with 6 thousandths. So the go gauge should be protruding from the back of your chamber approximately 6 thousandths past the tenon length. And you'll measure that with your depth micrometer from the shoulder to the back of the go gauge. And again, this is an approximate. You have to feel how the go gauge actually works in the action at that time. So when you start getting close to this number when you're chambering, you want to feel the go gauge, and you'll see that later on in the video. And this could vary a couple of thousandths. Either it should be larger, a couple thousandths larger, but it depends on the guy who cuts the go gauge and where the shoulder on the go gauge meets your chamber. This short section of video is an addendum to the chambering video for the Remington Action. I misspoke and used the wrong terminology when I was talking about the bolt nose clearance. The numbers work out the same, but I said recoil lug and actually had it written on the board, and it should be stated that that is the bolt nose clearance. That's why you add the 10 thousandths to the .134, and you come up with .144. That is the depth of your recess cut. Remember, that cut for the bolt nose is 708 thousandths wide, and it's 144 thousandths deep in this particular action. But I wanted to clear that up. And somewhere else in the video I mentioned the diameter of the recoil lug, and you don't measure the diameter of the recoil lug, you measure the width of it. So I used the wrong terminology there, and I apologize for that, but hopefully this will clear up any confusion that might have caused. Now, this is a complete listing of the exact tools or thereabouts that you'll need for accomplishing your chambering task. You're going to need an action. In this particular case, I'm showing a model 700 Remington, although we're going to be chambering for a 40X. Then you need the bolt. You need a bolt removal tool for the Remington. This is made by the K.W. Kleindendorf company. I call it my Dusseldorf tool because it's easy to remember Dusseldorf for some reason. You're going to need a dial caliper. In place of a dial caliper, if you have the option, use a mechanical one. They're a lot more accurate, and they're dead nuts, and you can get a better feel with them. You don't have to worry about batteries dying or temperature changes. This is the preferred tool. You're going to need a depth micrometer. Whether it's mechanical or digital, you're going to need a depth micrometer. This is critical for all your measurements on your tenon and your bolt face. Have to have one of these. You're going to need a range rod, the appropriate range rod or indicator rod for your particular chamber. You're going to need a set of bushings. Get a few bushings above and below the nominal measurement of the bore. You're also going to need some sort of a way to hold your reamer. This happens to be a Manson reamer holder, floating reamer holder, and I prefer this because it gives me my best results. I also use the Lambertiff reamer micrometer. This will give you dead nuts accuracy as far as depth of cut. Now, this task can be accomplished with a magnetic-based dial indicator. However, if you get the heebie-jeebies when you're moving your dial indicator in, or it gets stuck, you may cut to the wrong depth. So I use this because it's a no-brainer. It's very easy to use. This can be purchased from Pacific Tool. You're going to need some sort of a cutting oil. Now, I happen to use my own oil, which is Viper's Venom. It's a high-sulfur cutting oil. It works extremely well for threading, tapping, and chambering. But you can get any kind of a dark sulfur-based oil. This is not the oil to end all oils, but it does work very well, and I do sell it. The other thing you're going to need is 3 cutting tools. That's all. Just 3. You're going to need a threading tool. You're going to need some kind of a tool to face off with and just take off metal. And you're going to need a profiling tool. Now, the profiling tool has a 35-degree diamond, and it's made out of high-speed steel from the Arthur R. Warner Company. This is very handy for getting in and single pointing the recess or crowning the crown of a barrel. The recess being the recess on the back of the barrel for a Remington Action. The high-speed steel inserts are preferred, especially for cutting at low RPMs. You'll get a much nicer cut, and everything that we do is going to be doing slowly anyway, so you cannot accomplish the same finish with carbide at low RPM. So if you get a chance and you need some tooling, you can buy the inserts alone that'll fit the tooling you already have. They're not expensive. Or you can buy the tooling kits from the Arthur R. Warner Company. You'll never have to worry about running too slow. You can always cut nice cuts with this tooling. The other thing you're going to need is a reamer and a go gauge, the appropriate go gauge for the reamer. You don't need a no-go gauge. You do need the go gauge. You can always put a piece of tape on the back of the go gauge and it'll tell you that it's 2/1000ths longer, and you can check your chamber that way. Other than that, that's all you need to chamber a barrel outside of the barrel and a lathe. Now we're going to speak just for a second about indicator rods or range rods. They have a bushing on the front, and it's specifically ground for your particular caliber, and they're tapered from the front to the back. So as it goes in the bore, the bushing is guided in the bore, and then it will lock up at the appropriate place. And then this will become rigid in the bore, and we can indicate off of that. Now, if you have a 6.5, then you need 6.5 bushings, and you should get a variety of them. This happens to be a 7mm that we're working on today. And as you can see, the bushings come in various sizes, and it's important that you get a set of these because no two barrels are ever going to be the same diameter, and you would like that bushing to fit snug. I've already selected the bushing that I'm going to be using for this particular job, and I've fitted it in the bore, and it fits nice and snug with no play. I'm now going to put this on the indicator rod, 7mm rod, and we'll get to indicating. But it's very important that you have a precision ground indicating rod. Dave Kiff at PT&G Tools, Pacific Tool and Gauge, sells these, and they do a wonderful job of grinding them. In this segment, we're going to be dealing with dialing in or indicating your barrel in. In front of you, you see a 4-jaw chuck, which is an independent 4-jaw chuck, and you see a 4-inch diameter, 7-inch wide piece of round stock aluminum with 12 threaded holes through it with Allen screws, and each one is tipped with brass so that we don't damage the barrel or mar it. I have marked on each one of the 4 sides a set of numbers, 1, 2, 3, and 4. The reason for these are it gives you a reference point so you can remember what you're adjusting. If you tighten up 1, you're going to do the opposite on 3. You're going to loosen up 3, and this way you'll move the barrel into concentricity a lot easier. Now, I use this particular setup because I do not like to reach around the outboard side of my lathe to make the adjustments. The other reason is that my lathe is very wide. The headstock is very wide, so it makes it difficult to put a shorter barrel in. I do have other chucks that are narrow with a single cat face on this side and one on the outboard side so that I can dial it in that way if need be. This would be your spider for the outboard side. But this makes it very convenient because you can do all your indicating right in front of you. In a moment, we'll set up the dial indicators in a barrel, and it'll be off to the right, and then we'll be able to indicate it in from here. This fixture also works well for doing pistol barrels. I've got an extra 2 up close here so that you can indicate a pistol barrel in very nicely. The next step, before we try to find a bushing that's going to fit the bore properly and use our indicator rod, you always want to make a facing cut and face off the end of your barrel. During the turning process, when they're at the factory, a lot of times they'll get burrs in them or it just won't be a clean hole, and you won't be able to get your bushing to fit properly. You don't need to take a heavy cut. Just make sure you have plenty of oil, and you cut it from the inside out. You want a nice, clean, burr-free hole. This is the same technique that you use when you go to crown your muzzle. You always want to turn from the inside out and take very light cuts. It also helps to have high-speed steel inserts or some kind of high-speed steel tooling, because it makes a much nicer cut as opposed to carbide. And you can do it at low RPMs, which is a plus for the home hobbyist and the home gunsmith. Okay, we finished our cut. We've got a nice smooth cut, and we've got a nice clean bore, and now we'll be able to properly fit our bushing in there. After you've selected the appropriate rod and the appropriate bushing, so that's a nice snug fit, you then push the indicator rod, which is tapered, into the bore, and it automatically lines itself up with the center of the bore. Give it a light tap, and that locks it in place. Now we can set up our dial indicators and indicate off of this rod and know that it is dead center in the center of that bore. Alright, we've now got our PT&G range rod or indicator rod in the bore with the proper bushing. And we've got our 1000 style indicators set up here. I like to rough it in with the 1000 style indicators first because there's a lot of movement on 1/10,000 style indicators. And these will probably be a little bit easier to see in the video. Now you rotate your stock towards you, and you'll see that the dial, as we go to there, that's the high spot, and that's showing number 3. So put your Allen key in number 3 and tighten it just a little and bring that needle down. Hopefully you'll be able to see this move. There you go. The needle just came down halfway. You try to cut the distance in half each time. Now that needle is just a little movement now. There's low and there's high on number 2 now. So on number 2 we're going to give it just a little tightening and bring it up. Hopefully you got to see that needle move. Now the needle is dead nut still, not moving at all, which means once we put our 1/10,000 style indicators on, we'll probably be 2 or 3 10,000ths out. Now we'll look at the other dial indicator, which would be adjusted by the outboard spider if you're using an outboard spider. In this case, we're going to be using the left-hand side of our spider, which is right in front of our chuck. And this way we don't have to move to the outboard side of the headstock to be able to adjust it. So we're going to watch this dial now, and we're going to find the high spot. The dial's moving, and it shows right there. That's the high spot, and the high spot at this point happens to be on 2. So we're going to insert our key, and we're going to loosen this, and we want this indicator to move to the left. And as you see, it's moving to the left. Now whatever you do on this, on number 2, you must do on number 4, which is the opposite side. So we bring it to number 4, and this time, this is the low side. Actually, the low side. Now we're going to tighten it, and you'll watch the dial indicator move to the right. Now we'll turn it again. And we'll see the high side, the low side. Here's the low side. We'll go back to the high side again. Right there. And now it's on number 1. Put your key in number 1 and tighten it until you see the arrow start to go up a little ways. Rotate it again. There's the low side. It's on 3. We're going to tighten 3. And we're going to go around to 1, which will be the high side. There's number 1. And we're going to loosen 1. That'll bring the needle back down this way. There we go. See it? Now we'll rotate it. And the high side is back at 3 again, but we've cut the amount down. We're now going to tighten 3, and it'll move the dial indicator to the left. There we go. Now we find the low side again. And the low side this time is at number 2. So we're going to tighten it a little and move the arrow to the right. Hopefully you'll be able to see this. High, and there's low. There's high again, and there's low. Low happens to be at number 1 this time. Tighten number 1. And it moves the indicator 1/1000. Each time you try to cut the distance down between the two. Now we're rotating the chuck again, and we've got a low side and a high side, but we're well within a 0.5 or 5/10,000. Now we go back and we look at our first dial again, and you'll see that it's going out of adjustment. There's the low side right there. There's the high side. Once you start getting it this close, you try to do nothing but tighten. As you tighten it, you'll see the arrow move up. And it's getting closer and closer to the center point where it'll be not moving at all. Now we'll go back to number 4 is still the high side, and 1 is the low side this time. So we're going to loosen up on 1. Watch the dial come in. Moves right down into the middle. And we're going to rotate it again. And we'll see that 1 is on the high side this time. So we'll tighten it up. This time 3 is on the high side. So you tighten up number 3, and it'll bring the needle up just a little bit. High, and low, high. You want to tighten up number 4. Our indicators now is well within 0.4. Now we want to look at the outboard one again. And the outboard one is out of adjustment now. There's low, and there's high. You want to go to the high number, which in this case is number 2, and we're going to loosen number 2. And we're going to watch this move back down towards the center of our swing. Rotate it until you come to number 4, and then tighten number 4, and that'll bring the arrow back into the center. Now this procedure is not done quickly. It's very intricate, and you've got to take your time doing it. We're on the low side again. So we're going to tighten up number 2 and bring the arrow back to the center of the swing. There's low on number 3. You're going to tighten up number 3 and bring it back to the center of the swing. And that one's now within a 0.5. So, at this point we're going to change our dial indicators, and we'll go to we've still got this one out just a little. That's low, and that's high. We'll try to tighten it first and bring the number 4 down inside. It won't tighten anymore, so we have to go around to 2 and loosen it up. Just a little. Bring that needle in towards the middle of the sweep. Now we're at 4 and we're only 1/1000th out, so lightly touch number 4, tighten it up a little, and it brings the needle back to the center of the swing. And what you do is you go back and forth between these two dials, tightening or loosening the desired number until the needles don't move. Then when you're done with the 1000 style indicators, then you can move to the 1/10,000 style indicators, and that'll give you a little bit more precise dialing in procedure. We're going to continue with this because this will take some time, and once they're done, then we'll come back. Well, we're back again. It's been close to 40 minutes since we started indicating the barrel in, and right now, with the 1/10,000 dial indicators, they're reading absolutely 0. There is no movement in either one. Now, a lot of guys will settle for 2/10,000ths, but if you take your time, you can get it to the point where they are dead nuts 0. Now your barrel, your bore is perfectly indicated in and ready for the machining. Later on in the video, we will indicate the bore back in again to make sure that our machining hasn't taken it out of adjustment at all. But right now, that's as perfect as humanly possible. The action we're going to be chambering today is a Remington Model 40XBR. This one has seen a little bit of use, but it's still in good shape. And you can see where it was bedded down here. But this is the action we're going to be chambering for today. Alright, we're now going to continue from where we left off doing all our numbers and our math. We've now cut the barrel tenon to .955. That's from the end of the barrel to the shoulder. That is called the tenon. And 955 was the measurement that we came up with the formula that we've previously gone over. Now, I've already taken the liberty of cutting the major diameter of the tenon, and I cut it to 1.062 because that happens to be the diameter of the lug. And as you'll see, the lug fits on there nice and snug and doesn't have any kind of play in it. And that's the way you want it. You want this lug to be sitting nice and tight, and you want it to be sitting on a shoulder, not on threads, and I'll show you why. Here's a barrel that was chambered where they threaded right up to the shoulder, or almost up to the shoulder. And when you put the lug on it, it's got a lot of play, and you don't want the play. You also don't need threads underneath this. So we're going to make a nice clean shoulder here, and we're going to cut the relief cut for the thread underneath this lug so that when you butt the barrel up against the action, it's going to be flush up against the lug and not up against the shoulder that we're going to leave underneath. We don't have to worry about cutting this to the right diameter yet because we want to get the lug on there properly. And as you can see, it is on there properly at this point. Okay, we are about to cut the relief cut for our threading tool. And we're going in 10,000ths short of the locking ring. And that's all we need. We want to go a little bit deeper, but we don't want to go any further back. There we go. That's perfect. That'll give us enough relief for our threading tool to empty out into clear space, and yet we've retained that 1.062 collar for the recoil lug to sit on. Okay, earlier we mentioned that the collar diameter that's going to hold our locking ring on is 1.062. We're now going to take a 2/1000th cut off of that major diameter. That will give us our perfect diameter for threading, which is 1.060. This is important because if you don't cut it down to 1.060, you're going to end up having very pointy threads. And we don't want pointy threads. You want to have a flat top thread. This way you'll get full engagement in the threads in the action. Make sure you use a good sulfur-based cutting oil when you're doing this. And when you can, use high-speed steel inserts or some kind of a high-speed steel tool. Doesn't create much heat and it makes a very nice cut. You'll have a hard time cutting 2/1000ths off with a piece of carbide or a carbide insert. Our 2/1000ths cut has now been made.